Okay, next up in our code and deploy track, we have a veteran Atlassian, Ian. He's behind me. He has actually been at Atlassian for 7 years, and I think he's worked on every single one of our products, either in a full-time capacity or in like his 20% time. So I think that's pretty cool. So without further ado, I'm just going to let Ian take it away.
Good afternoon, everyone. I'm Ian Grunert. I've been at Atlassian since February 2011, and since then I've shipped countless performance improvements across Jira, Confluence, Hipchat, Bitbucket Cloud, and Bitbucket Server. I spent a couple of years on Confluence, and then after taking a break, I'm now on the Trello team working on performance and scalability full-time. So previously on one of my blog posts about a performance improvement, Scott asked, how am I able to find and fix these performance issues, and what can others learn from my approach? So I'm here to help try and answer that question to some degree and give you a bit of an insight into some of the things that I think about when looking at web performance and hopefully give you some ideas that you can take away to help improve performance within your engineering organizations. It's very easy to let performance slowly slip over time. It's a classic frog in the pot situation. With slow enough degradation of performance over time, you won't notice a difference from release to release. It's only when you look back 3 months or 6 months or 12 months that you realize just how far you've slipped from where you were. So what we want to do is help turn that ship around. We want to get some forward momentum behind performance improvements to prove that it's possible for the applications to be fast and help lay the groundwork for establishing a culture of performance in the engineering org. So today I'm going to talk to you about 4 main things. The first is being data-driven, so measuring first and then optimizing. There's no point in shipping an awesome performance improvement if you don't have a cool graph to be able to show exactly how much you've improved. Then I'll talk a bit about investigation, so common pitfalls you can look for in your web applications, some things that I look out for when I'm doing some initial investigation for web application, and ideas for getting started and starting to build that initial backlog of performance fixes. A little bit on planning, so focusing on impact and how to establish momentum and how to think about performance while doing your planning. And then a bit about celebration and how you can share the wins with the rest of the organization and the benefits of doing so. So to start off with, I'm going to talk about being data-driven. So I think that you should be focusing on real user monitoring first, or RUM. So who here collects real user monitoring for their web applications? Okay, there's a couple of people, but not too many. So this is probably the most important takeaway for you for this talk. Real user monitoring gives you a real picture of what end users are experiencing. So rather than focusing too heavily on back-end metrics exclusively, which is not usually where the largest wins are, by collecting real user monitoring, you're getting data from end users' browsers about exactly how those applications are performing for them. So start gathering this as soon as possible with a tool of your choice. Ideally something off the shelf, because it's very easy to spend a lot of time building out custom data storage and reporting infrastructure around collecting real user monitoring data from browsers, and you don't get a huge amount of benefits in terms of value shipped to your customers from that. Once you have the initial set of data around real user monitoring, you'll likely determine where you need to beef up your monitoring, particularly around back-end stuff, but also around front-end stuff. Don't get too lost into the weeds though, because it's very easy to spend a huge amount of time just trying to gather information when really there's going to be a couple of pretty easy low-hanging fruit for you to be able to pick off and start delivering some value to your customers. So once you get real user monitoring, you'll get a breakdown of what a typical user request looks like. It will look something like this. There'll be some redirects and unloading from the previous page that the user is on. There'll be some DNS work to convert a URL to an IP address, TCP connection establishment, followed by making the HTTP request for the page thereafter, getting the page and downloading the associated JavaScript and CSS resources, and then executing some JavaScript to be able to render the page and potentially do some more work after you've got that initial information. So the 3 that I think you should be focusing on mostly are, or the areas that you should be focusing on are here, around server processing, sending the response, downloading and parsing the CSS and JavaScript resources, as well as on the JavaScript work done after the page is rendered. And with these items, you should be establishing what your baseline looks like and starting to set some targets around them, because these are the things that are probably going to dominate what the request breakdown looks like. And some of them are also the ones that you have the most power over changing. So as I was saying, downloading and parsing the CSS is usually one big ticket item, because JavaScript and CSS resources in modern web applications are often extremely large bundles, and there's quite often a couple of low-hanging fruit around slimming down those bundles or splitting them up or doing other work around them. Secondly is around the JavaScript rendering process, so whether that's doing additional HTTP requests to be able to fetch data to render the main content of the page, or work around just parsing and executing the JavaScript, can easily dominate the render time for a typical page. And thirdly is server processing, so the work done in your servers to be able to generate the initial HTML response. This is the thing that you probably have the most control over, because you pay for the hardware and you're the one who wrote the code for that, instead of it being whatever browser end users decide to point at your site on a little Raspberry Pi that they have underneath their desk. So setting a ambitious target around server processing is pretty important. So once you've started to get the data together, and you're starting to do a little bit of reading around performance improvements and what you can do, it can get a little bit overwhelming. You want to start diving into investigation and backlog generation, but working out where to get started can be a bit difficult. When you start to read, you'll read about things like flushing head early, tree shaking and code splitting for your JavaScript resources, HTTP2, Quick, GraphQL, TLS handshakes, CDNs. There's so many things to think about when talking about performance. And there's just so much information out there, it can become pretty daunting to work out where we should get started. But honestly, the best thing you can do is just to start using the tools that are readily available for you to start doing some investigation and backlog generation, and see how far you can get from that. You don't really need specialized tools or an encyclopedic knowledge about how web applications work end to end to be able to start to find some things to improve. Usually just a couple of rough passes with your browser dev tools or with some other tools and a little bit of persistence and tenacity can uncover a few things that need fixing straight off the bat to establish some forward momentum. So for example, I just recently started on the Trello team a couple of months ago, and I decided as part of this presentation I should probably fire up a board and start to do a little bit of investigation. So I found this board from one of the older blog posts about Hawaii vacation, fired up the dev tools, did a performance run, and started to look into where the time was being spent. So what am I looking for when I do something like this? I start off with looking for where DOM content loaded event end is. So that's the event that gets fired when all of the CSS and JavaScript is being downloaded and the JavaScript that's associated with the onReady event has finished executing. So this is a decent proxy for how long it takes to load the page. There may still be other stuff that happens after that, but this is a good starting point. Once I know where that is, I want to understand where the rough breakdown for that is and where the dominators are. What's the long pole? What's taking a huge amount of time there? Is it spending a lot of time downloading CSS and JavaScript? Is it spending a lot of time in JavaScript execution? Is it spending a lot of time on the server backend? And then I also look at when the first meaningful pain is. So there's the screenshots section of the Chrome DevTools, which is this kind of timeline here. And that shows you that while DOM content loaded event end was here, it was a couple of hundred milliseconds after that we actually saw the board get rendered for the first time. So this here is also kind of interesting information to see what's happening between those two. So in addition to Chrome DevTools, you can also use web page tests for getting information like this. So web page tests is a free to use tool, and it's extremely powerful because you can set both test location as well as what browser to test your website against. So you can see what a Firefox user in Europe experiences when they're loading your page. It can also go pretty deep in terms of auditing. You can launch a DevTools inspector from web page tests, and it has pretty useful audits out of the box that are quite similar to the ones built into Chrome. So I pointed that Trello board that I was looking at web page tests, and you'll notice that while we have a good first byte time and keep alive is enabled and the compressing of transfer is NA, these two here, we got Fs for compressing images and caching static content. It turns out that on older attachments for Trello, we were missing cache control headers on attachments that were uploaded by end users. I managed to find this issue within a couple of minutes of just poking around, and we were only just getting started. So it's pretty easy to just jump in, do a couple of quick and easy passes with some simple tools and start to get some content for our backlog. There's a few other things to look for with images as well. You can check that they've been optimized and compressed correctly with software like Image Opt-in, and make sure that you're performing server-side rescaling of images instead of browser-side. It's very easy to send down a wallpaper-sized image and then resize it on the browser to a postage stamp, and all those bytes down the wire are just wasted. And that can cause a pretty big difference in perceived performance for your end users, particularly for people on mobiles or people who are living in Australia and have shitty internet. So I'm just going to talk a bit about CSS optimization next. So it's pretty easy to get pretty big CSS bundles in web applications these days. CSS and JavaScript just is kind of growing over time as modern web apps pull in more and more libraries, and we get further and further abstracted away from the CSS that we're writing. So when we're first looking into stuff like this, then setting a custom latency profile is pretty important. There's no out-of-the-box latency profile that adds enough latency to simulate your users being far away from your servers. They're all based around the idea of what a 3G connection and 4G connection is, but it doesn't actually add the extra latency to hop to the server. So when I'm looking at big CSS bundles, the first thing that I look for is inline images. It's a practice that was very popular for a time, as you can eliminate a server round trip to get an image, which is good to reduce the number of HTTP requests when you have a huge number of small images on a page. However, for images above a very small size, it's often better to allow the page to render without image first and let a regular image tag pop them in later, particularly if you set the dimensions on the image tag correctly to prevent the page from reflowing and jumping around. The advice of inlining images into CSS has caused a lot of well-meaning devs to add a very large amount of page weight to the CSS, particularly when naively inlining unoptimized or not scaled PNGs, or SVGs for that matter. They can balloon up to 130% of the original size, growing. If the images are already like a larger unoptimized PNG, then the base64 process to be able to inline it into the CSS can cause pretty big page weight increases. So just take a quick look around your CSS to try and find large background images. It doesn't take long to do a couple of greps across the CSS files that you're serving, and can pay pretty large dividends in terms of tens to hundreds of kilobytes saved from the CSS that blocks users from being able to render the page. So an example of this, I found this SVG file in Bitbucket Cloud in 2014, which was 78 kilobytes to start off with, and when it's inlined, it balloons out to 104 kilobytes. While it was sent down the wire gzipped, it still accounted for the majority of the bytes down the wire for the initial HTML for the dashboard of Bitbucket, as it was inlined into its own style block within the initial HTML. Better yet, this image was completely unused. It was an unused rule based on a previous dashboard design, and I just removed the style block entirely, and I no longer had to download 100 plus extra kilobytes every time I loaded the dashboard on my shitty Australian internet. So often when working with a web application over time, it's easy to forget to remove an unused CSS rule after you've changed your designs or you've changed libraries or something like that. It's particularly true for CSS, where it's not always straightforward to determine if a given rule is still in use or not. So you can use the Chrome Audits tab and the Unused CSS Audit to hunt down potential extraneous rules in your CSS on your pages as a starting point for investigation. Just because a rule shows up on here doesn't mean it's not used at all entirely within your application, but it's a decent starting point to be able to find some potential wins. I'll just talk a little bit about JavaScript optimization. So another smell that I look for is waterfalling in XHR requests. It's easier to accidentally turn what could be 3 sequential requests to your backend into 3 concurrent requests to your backend into 3 sequential requests due to the way that you layer your JavaScript. This is particularly painful when we're fetching data for the front end to render client side to do that first paint of the page with JavaScript like client side rendering, as it's on the critical path for the user actually seeing the data that they care about. So this shows up firstly on the network tab. You can see down the bottom here, bottom right, it's probably hard to see, but you see you have this this request happens and then the next one and then the next one, and it also shows up on the performance tab as this one and then the next and then the next. If you can roll them into a single, into either one request to the backend or 3 concurrent requests, you can save quite a few round trips to your backend. This is something that I did in Jira Agile in 2012, 2013, which is now Jira Software. At the time it was Greenhopper. It's very confusing. So a tip to avoid these kinds of problems in the future is to add artificial latency to your dev environment, because it's very easy to add these kind of issues in your dev environment because you have 1 to 2 milliseconds latency to the local server. So this is something that Trello does actually. They add 500 milliseconds to every request to the backend on the dev server to be able to highlight issues like this where you've added sequential XHR requests. Now, JavaScript also suffers from a weight problem of when we're developing under using modern practices. It's very easy to pull in libraries that pull in hundreds or megabytes, hundreds of kilobytes or megabytes of JavaScript. But on the flip side, it's easier than ever to actually find where all the JavaScript is coming from when you use newer bundling solutions like Webpack. So the Webpack bundle analyzer can produce pretty looking visualizations like this, which could make it pretty easy to drill down and find potential wins, find where all the JavaScript is coming from so you can work out what to optimize. And that optimization may mean just actually minifying some JavaScript that wasn't previously minified, or it may be identifying extraneous JavaScript where, say, you're pulling in coding highlighters for Fortran, and it's pretty unlikely that anyone cares about code highlighting for Fortran in your application. Or it may be identifying large swathes of code that you can load in asynchronously when the feature is triggered, instead of it being in the head blocking the rest of the page from being rendered. So now we're going to talk a bit about server optimization. So start out by talking about profiling. So just some quick and dirty profiling can go a long way to identifying potential wins on your server side. Connecting a profiler to your local dev environment and firing off some sample requests around the rough data shape that you expect can pretty quickly uncover a few issues if you know what you're looking for. Secondly, I'll talk about data access. So looking both at individual query performance through looking at your slow query log, and also looking at number of queries per request is pretty important. While the slow query log is the obvious thing to look for to start off with, because you'll find a SQL or whatever database you're using request that's taking tens of seconds, but number of queries per request also matters a lot, particularly when you have 1 to 2 milliseconds latency to your database in typical cloud environments these days, because that 1 to 2 milliseconds when you do hundreds of requests to your database per request adds up to be a dominator for the total response time for that request. Thirdly is monitoring. So production monitoring can uncover data scenarios you're unaware of, or it can just highlight issues that you hadn't even thought about. Just keeping an eye on your monitoring can cause you to find some pretty amazing wins. So I'm going to start up by talking about a win that I found through profiling. So I spent a little bit of 20% time looking at Hipchat Cloud a couple of years ago, and I noticed that loading the initial HTML for the Hipchat web client was taking significantly longer than I would expect. So I decided to fire up a profiler and take a look into what the application was doing. And I noticed that it was spending about 30% of its time on this preferences get multiple area, which is getting like user preferences. So we would have a set of preferences for a given client, so whether we should notify for given rooms and what the notification settings are, and there was about 16 of these things, and we would call through to, for a user, get the preferences object, and we would get the set of clients' preferences using this get multiple method. And then looking at the code, get multiple for each key that we requested would call get, and get would then call get all to get all of the preferences data associated with that user and check for that individual key. So what was happening was we called get all 16 times, but really we only had to call it once up here, and then we would have all the data that we need to be able to do it, to be able to resolve the request. So this was a nice little win that took me, I don't know, a couple of hours to find and put together a pull request for, and maybe another couple of hours to be able to get it deployed out to production. And we saw a decent win here. It was like 200 milliseconds on the median for the index page, which for a couple of hours work, I think is a pretty amazing win. So next up, I'm going to talk about listening to your monitoring. So once you've set up some backend monitoring using something like New Relic, or you could be using Kibana or Grafana, whatever. If you take keep an eye on those graphs and maybe take a look once a day or a couple of times a week, you can often uncover some pretty interesting things. So I opened up New Relic for Hipchat on a given day a couple of years back, and I noticed this graph where the establishing of a Hipchat session had suddenly doubled in how much time it took. So it started out at about 500 milliseconds and it ballooned out to a second over the course of a couple of hours of slow ramp up. So I decided to poke in and take a look at what an individual request looked like for this using New Relic again. And I noticed that it was spending a huge amount of time in constructing these Tetra service models. So Tetra is the backend chat service, the chat server. And what had happened was we had scaled up how many chat servers that we had. And in doing so, we had inadvertently made these requests significantly slower, because in order to choose a random chat server for this client to connect to, we did a huge number of Redis queries to be able to get information about every single chat service, and then we threw most of it away and picked one of them and used that one's data, and all the rest of those requests were null and void. So in fixing this up, we started out with the chat index, the web client mainframe, loading the web client, taking over 750 milliseconds at the median to be able to render out just someone goes in and wants to load the Hipchat web client. And I deployed and saw the graph went like this. We started out at around the 800 millisecond mark at the median, and it's dived way down to about 100 milliseconds. And this here is the 99th percentile. It's gone from about 1.5 to 2 seconds all the way down to 300 milliseconds, which was a massive win. We also saw a similar win across on the endpoint for establishing a chat session, which is a nice huge win as well. And going from over 750 milliseconds to about 100 milliseconds on loading the web client is a pretty massive win, just from taking a look at some graphs and having a think about what would cause the graphs to look like that. So that's a pretty big win for using monitoring and thinking about your monitoring and looking at your monitoring over time. I'm going to talk about planning next. So whether it's an individual who's got a little bit of slack time to be able to do some of this stuff in 20%, or a team that's doing a new feature and looking at doing a feature kickoff, or you've got a dedicated performance team, it always pays to do a little bit of planning before you jump into this kind of stuff. So to start off with, we rank on estimated impact. So take a look at the backlog of potential fixes you've managed to build up while you're doing some investigation, particularly if you do a lot of upfront investigation on what JavaScript you can get rid of, and just do a little bit of a rough ranking on which issues you think are going to be the highest impact. But don't stress too much about trying to predict it. You'll get much better over time at predicting for a given potential performance fix what the win is going to look like. And often it would take less time to just fix the issue and see what it's going to look like in production than it would be to try and form an accurate model of how much performance win you're going to get out of doing something. So just don't spend too long on planning. Start to get a backlog together, a little bit of a backlog, do a little bit of ranking, and then just get started. Start to get some performance fixes out the door and establish some forward momentum. Once you get some forward momentum, it starts to prove what's possible around how much you can move the graphs and how much you can improve performance. And that also helps boost morale for the team to be able to convince them to continue to work on these kinds of things. And for new features, just talk about performance in your next feature kickoff. Who here does feature kickoffs for new features? All right, one person. So that's another thing in the playbook that you can start to look at is around feature kickoffs. It's a little meeting that you do before implementing your features. It's kind of like at the end of doing a feature or a project or whatever, you do a retrospective. This is doing that upfront to start to talk about the risks about a feature and some of the goals for that feature and that kind of stuff. When you do something like that, you should talk about performance from a risk standpoint. Start to talk about the different ways that the things you could do while implementing this feature could regress performance, as well as from a goal standpoint, start to talk about how you would like this to perform. What are the goals around performance? What's the acceptable bar and what isn't acceptable? It's very easy to just assume this is like a non-functional requirement, but really it's pretty core to the user experience as to how fast it is. Just start to make performance part of that conversation around feature development. So next up, I'm talking about celebrations. So once you've got some wins, you've established your backlog, you've started to get some wins out the door. Next up is celebrating those wins and starting to share them with your team. If you've got a small win that's kind of localized to a particular team, then just dropping a graph into a Stride room can really help make the team aware of the kinds of work that you're doing and just bring people up to speed as to what we're trying to improve. So here, for example, I dropped some graphs into the server Trello room after improving email rendering performance. So I just pulled this quick graph off of Grafana that you can't see because it's extremely dark. But trust me, it goes from bad to good. So for quick wins, that's great. But for larger wins, you kind of want to share with the wider company and bring performance into the conversation for the bigger company. And this is where Confluence comes in for Atlassian. I like to do these blogs out to the wider team about the kinds of things that I do. And I pull the pretty looking graphs and throw them on there and not just explain the value that I just delivered and how it improves the customer experience, but also try and explain the process by which I found the issue in the first place to try and inspire people about, look, this isn't rocket science. I just am looking at a couple of key tools, trying to understand the data that they're telling me, doing a little bit of investigation and often putting through what is here, you can see a 4-line fix or something. So by doing that, you can help improve people thinking about performance and thinking about, hey, it actually isn't that hard to start to move the needle on these things. Maybe I should take a look next time I have a spare 20% time day or a spare afternoon to mess around on this kind of stuff. So here's another example of a blog post that I threw out there, which is talking about the win that I was talking about for the Hipchat web client earlier. And you see that I get a lot of response on these kinds of blog posts, a lot of people commenting and asking about this stuff, a lot of people motivated to start to write their own performance improvements, but also just a huge response from the company in terms of the number of people liking these kinds of blog posts. This from a couple of years ago, so 192 likes is a pretty substantial portion of Atlassian back then. And the blog post is on the popular tab for a solid week, which really helps elevate performance as part of the conversation, as part of what people think about. And this is where that quote from Scott came from earlier, of people, of him asking me, how do I find this kind of stuff? And often it's just I spend the time and look at it, it's really not a huge amount of work. It's not hard. As much as from the outside looking in, it looks like it can be hard. It's often just a matter of time, spending the time thinking about performance, caring about performance, and starting to make some forward momentum. Thank you very much.